Welcome to solverfy.
In this question, we have two links, link AB and CE. And in this question, block A is moving downward with the speed 4 meters per second. And then we need to find VE in this question. Okay, so let me just outline the steps. First, we need to find omega AB. Okay, because the angle is VE, so to find VE we need to have omega CE. After finding omega CE, we need VD. Yeah, because with VD and omega CE, then we are able to find VE. Okay, and then but to find VD, we need omega AB. So that's the reason why the steps are like this. Okay. Okay, so now it starts with 1 to find omega AB. Okay, so we are given that VA is minus 4J, and then VB, using the relative velocity equation, is just VA plus omega AB cross R, position B relative to A. So this is equal, and then from the question, VB is moving to the right when A is moving down. Okay, and then consequently, or at the same time, rod AB would turn clockwise. Okay. Yeah. So when it comes to here, we are going to write VB along the I direction. VA is minus 4J. Omega AB is clockwise, so omega AB along the K cross the position vector of V relative to A is 0.55 minus cosine theta I plus sine theta J. Okay, and then in this question, the theta is this, and then we are also given a triangle over here. Okay, so this is 5, and then 3, 4. So this means that sine theta is going to be 3 over 5, and cosine theta is going to be 4 over 5. Okay, so continue to do the steps. So minus 4J plus 0.55 omega AB. We have 3 over 5 I plus 4 over 5 J. Okay, so minus K cross minus I gives positive J. Cosine theta is 4 over 5. Then minus K cross J is positive I, and sine theta is 3 over 5. Okay, so VBI is 0.33 omega AB I plus 0.44 omega AB minus 4. Okay, J. Okay, so we only need omega AB, so this means that omega AB is equal to 4 divided by 0.44, and this is equal to 9.09 radians per second. Okay, we only need omega AB. VB can be found, but it's not required. Okay, next 2 is to find VD. Okay, so VD is equal to VA plus omega AB cross the position of vector of D relative to A. So this is minus 4J plus minus 9.09 along the K direction cross 0.3 minus cosine theta I plus sine theta J. Okay, So just recall that this is 4/5, sine theta is 3/5. Okay, then this is what we get, minus 4j plus 1.64i plus 2.18j. Okay, this is the result of the cross product. Okay, then you get 1.64i minus 1.82j. Okay, then next we are going to find omega CE. Okay, to find omega CE, we need to use point C, because point C is confined to move horizontally, so we can at least we know that one of the components is 0, so we can find omega CE easily. Okay, so using relative velocity equation again, Vc equals to Vd plus omega CE, okay, which is the same as omega CD cross the position vector of C relative to D, and Vc is going to move to the right, and then 1.64i minus 1.82j, so this is Vd plus minus omega CD. Okay, I'll just assume to be clockwise, and the position vector is 0.4 minus cosine 30 degrees I minus sine 30 degrees j. Okay, then continue to work on the numbers. Plus 0.2 omega CD. Okay, so cosine 30 is square root 3/2. This is half. Okay, and then yeah, so the half is factored out. Multiplied by 0.4 gives 0.2. Okay, then the omega CD just carry it forward, and then this gives I minus root 3j. Okay, so this is minus k cross minus I, so it gives positive j, sorry, and then minus k cross minus j gives minus I. Yeah, so this is the correct one. Okay, then we have 1.64 minus 0.2 omega CE I. Then we have plus 0.2 root 3 omega CE minus 1.82 j. Okay, so compare components. We only need omega CE. Okay, so omega CE is equal to 1.82 divided by 0.2 root 3. Okay, this is equal to 5.25 radians per second. Okay, then move on to the next. The last step is to find VE. Okay. Okay, so using the relative velocity equation again, VE equals to VD plus omega CE cross R, the position vector of E relative to D. So VD is 1.64I minus 1.82J. Okay, plus minus 5.25K. This is omega cross the position vector, which is 0.3 cosine 30 degrees I plus sine 30 degrees J. So this is equal to 1.64i minus 1.82j plus 0.787i minus 1.36j, and then I get 2.42i minus 3.18j meters per second. Okay, so the magnitude of VE is equal to 2.42 square plus 3.18 square root. Okay, you can find this to be 4.00 meters per second. And then the direction is tangent of 3.18 divided by 2.42. This is 52.7 degrees to below the horizontal. To the right. Okay, so yeah, because this is pointing in this manner, okay, and then this theta is 52.7 degrees. Okay, so the final answers, okay, for VE, yeah, so this is the answer. Okay, and that's all.